Okay, solving quadratics, real-life applications. The function for a dolphin jumping out of the water is y equals negative 16x squared plus 20x. They give us the function. We need to find the time that the dolphin is out of the water. So what we can do is just rewrite this function. This is a function of height. So it's h with respect to t equals. Now instead of x's, I'm going to use t's. Okay? I can say negative 16t squared plus 20t. So if they want me to determine the time, that means I got to solve for t. I got to find the x-intercepts, the solutions, the zeros, okay, the roots. I set it equal to 0, and I just solve for my t. Now, based on what we did Tuesday, what does the negative 16 stand for? Quick review. What's the negative 16 stand for? Anyone know?
The height from where you drop it at. Okay.
No, well, this will calculate the height, but the negative 16 is gravity. And does anyone remember what the 20 was for? In front of the t? When we did the free falling, we didn't have this here, did we? We just added the height, and that's it. So we didn't have this b value. Anyone remember what that's? Velocity. That's actually the speed. This dolphin is traveling 20 feet per second. This is velocity. So 20 is my velocity, and that is 20 feet per second this dolphin is moving. Okay? Just a quick little reminder. Okay? And 16 here, well, that's just representing gravity. So here are two numbers, what they mean. We don't need to know what they mean to solve for t, but, you know, it's nice to understand this completely. So, I solve quadratics by factoring and t-boating. How do I factor this? How do I factor this? What do I do? Is that two-cheek or one-cheek situation? Two. So I need to find something that multiplies to be what and adds to what?
Multiplies to be 16, but adds to 20.
No. What's, okay, this is the ending height, right? This is the ending height. The starting height is technically this right here. That's why we don't have it. Let's imagine, if we will, our dolphin, here's the water. Our dolphin. Got a little dolphin thing right there. That's bad then, right? You know, it comes out like that, then you got a bottle nose and it comes out. That's a bad dolphin. But the one I drew in the other class is better. This stuff goes swimming with it, and then like, boom, breaks the surface. Jumps up, and let's group it all because I hate when it ungroups. Jumps up, turns down, comes back in the water. So my dolphin is going to break the surface of water, come up, then come back down and splash back in right here. Okay? Yes. So 0, this is the height. This is sea level. 0 feet. That's the surface. He's going to break it at 0 feet here, and hit it again here. So now back to our quadratic. I don't need to have this ending 0. When I add 0 to anything, it remains the same. So there's nothing to multiply to. I should add to the middle term 20, but multiply to be 0, which is the last term. There's nothing that multiplies to be 0 that adds to 20. Well, 20 and 0 do, but here, that's 16 there, whatever. If there is, what are the golden rules? If there is a variable squared, like t squared, and there's no number without a variable, it can't be 2 cheeks, it has to be 1 cheek. Meaning, if I do this, I don't know, maybe that's 2 cheeks, I have to factor and see, I would try. But I need to have this and this both present in 2 cheeks. If not, it's 1 cheek, which means what? What can I factor out? Both of you are right, a 4 and a t. A 4 and a t. So I'm going to pull out the 4t. And remember, that's dividing, right? What will be left in the parentheses? Any guys can figure that out? I wouldn't say any guesses, but you guys should be guessing. You should know. You got it. Negative 4t plus 5. Now you can say, well, that's one cheek. Technically, it's two cheeks still, because you can put this in its own parentheses if you really want it. Right. Now you can T-bone. You can T-bone that and solve. So, set both these equal to 0, and solve them, and let me know what you get. All right, so as we solve these, well, I got to the T alone, so I'm going to divide by 4. So I've got T equals, this is still 0. When I evaluate this, I still get 0. So I have 0 seconds. And what about this?
Add 5.
Thank you. And then what?
Divide by -4t.
You got that. -4t equals 5. If I divide by -4, well, we said add 5. We got to subtract 5. This should be subtraction. And how did I know that? Because when I divide by -4, well, first of all, the opposite operation was wrong. But when we go through and we check our answer, now I get T equals 5/4, which is 1.25. If I would have left that, if I didn't flip the sign, I thought it would have been negative time. And that wouldn't have worked. So there's two answers, 0 seconds and 1.25 seconds. How long was the dolphin out of the water?
1.25 seconds.
1.25 seconds. He obviously came out of the water. He was out of the water for some 6 seconds. It wasn't 0 seconds. So this is how long he was out of the water. But here's the question. What does a 0 mean? Remember, if we have our little dolphin dude here, and I'm going to... This is really shoddy, I know. Yeah, it looks like a ghost. So...
That looks like a leg.
It does. Jumps up. Yeah, it's the what? Not the ending height. Remember.
Starting in ending height.
He come not height, but it's the time, right? If it takes 1.25 seconds that he's outside of the water, that's how long it takes him to get back into the water, right? And at 0 seconds is when he first comes out of the water. From 0 seconds to 1.25 seconds. So let me ask you a question. What time between 0 and 1.25 do you think the dolphin was at his highest point? We'll say the highest point is probably like right here in the middle, don't you think? That would be a vertex to a parabola, wouldn't it? Well, what would the time be? And why do you say 0.625? Yeah, that's exactly halfway in between here. You know we can check that. Not only can we check that, but if we have that time, we can figure out the height this dolphin achieved. Watch. Watch. My original equation, h of t equals -16t squared plus 20t. I need a coordinate. I need an x and a y value. X is my time, and y is the height. Now, how can I figure out the x value?
Plug in that 6.65.
That will give me the y value. Absolutely. But how can we make sure 0.625 is our actual middle value? How do I find this? X equals, remember our axis of symmetry? Negative b over 2a. What's my b value here? 20. So that's negative 20 all over 2 times my a value, which is negative 16. That's negative 20 over negative 32. And if you do that in your calculator, what do you think you get? 0.625. That's your x value. You were right. It's actually halfway between. The math proved it. So if I have 0.625 here, now I can find the height. And how do I do that? Yeah, I just plug my x value in. And for this, it's going in for time, right? So my y value is going to equal negative 16 times 0.625 squared plus 20 times 0.625. That's going to be the height. Tell me what you guys come up with. I'll do it up here as well. Negative 16 times 0.625 squared plus 20 times 0.625. What do you guys get? 6.25. We get 6.25. So guess what? This dolphin went a little over 6 feet out of the water. It's a coincidence that those are the same numbers. It won't always happen. Where the decimal just slid over once, it won't always happen like that. That's coincidental. But this dolphin right here was traveling 20 feet a second, was out of the water when he jumped for 0.65 of a second, a little bit more than half a second, and he went a little more than 6 feet above the surface of the water. Okay? Record this later. So let's look at this dolphin. This is SeaWorld in California. Look how high that rope is. Just Duncan the dolphin, by the way. That's crazy, right? Let's watch it again. I love that. Bam. And you'll notice, and we're going to time how long Duncan's out of the water so we can figure out how high he actually went in the air. That's nuts. I love that every time I see it. All right, so let's time how long he's out of the water for. Now, we just timed how long Duncan was out of the water, and he was airborne for 1.70 seconds. Okay? Now, we need to write the function to represent the height of the dolphin from the video, which is Duncan. Duncan's our main man here. I'm going to do that instead of Dunkin' Donuts. I'm going to make that a C. Duncan, right there. Now, we know the height with respect to time is, what does it always start with? Negative 16t squared plus our velocity times time plus our starting height. In this case, the water surface where we start, it'll be 0, right? Okay? And it's going to end up equaling 0 when we solve for t. So, if we know the starting height is 0, we really don't have to add 0. It can just be that. Now, we need to figure out the velocity. Velocity for this equation right here is measured in what? The first dolphin that jumped into the water 6.5 feet, how fast was he going?
20 feet per second.
Feet per second. I actually looked up the max speed for bottlenose dolphin is 21.7 miles per hour. We can convert that to feet per second. Or better yet, we can use our time to figure out the velocity Duncan was going. We should do that. Then, because I don't know if he's actually going the max speed. Maybe he's going a little bit slower, maybe he's going a little bit faster. So let's figure that out, and then we'll figure out what the max speed is and see if he was actually beating that or not. So, we know that our end height was 0, correct?
Yep.
Negative 16, time is what? 1.7 seconds? Squared plus v times time again, which is 1.7. I need to solve for v. Got it. What should I do here when I'm solving for v? For velocity. Yeah, what is negative 16 times 1.7 squared? Negative 46.24. Plus, and then it's 1.7 times v equals 0. Right, correct. We're going to add 46.24 to both sides. Yeah, 46.24. I'll be okay. So I now have 46.24 equals 1.7 v. I divide by 1.7, right? So, Duncan's velocity was what? Give me one decimal place. 26.7, and that's feet per second. No. Got it or no? Got to do it again? You want me to do it? 46.24 divided by 1.7. 27.2? Okay, so that is 27.2. Now, I can write that, put that in velocity. So our function of height is negative 16t squared plus 27.2 v. Or excuse me, t, sorry. That is our function right there. Now, how can I figure out what the max speed is in feet per second for a regular bottlenose dolphin? Well, if it's 21.7 feet per second, miles per hour. That's 21.7 miles per hour right there underlined in red. Well, there are 5,280 feet per mile. So if I go 21.7 miles, that's actually 114,576 feet. All right? Now that's how many the distance I'm going per hour. I want it per second. So we've got to break that up into 60 from hours to minutes. So if I divide that by 60, that means I go 1,909.6 feet per minute. If I want to figure out per second, the top speed is about 31.8 feet per second. Duncan's going just under that. So that's actually pretty close. That's actually pretty close, isn't it? So that's good. We did good. We did good. So, how can we find out the max height? That dolphin just jumped right there. If I have my water, the dolphin jumped out and came back in. And what was it, 1.7 seconds? Here's at 0 seconds. We should hope that the middle is right at what? What's half of 1.7? 8.5? Well, 0.85? Let's see if that's correct. Our vertex will give us the time and the height. The time the max height occurred at, and what the max height was. I got to use my equation here. So y equals negative 16x squared plus 27.2x. Why don't you guys figure out what the x is and figure out what the y is? Let's take it to it. All right, so x equals negative b over 2a. That is negative 27.2 over 2 times negative 16. What do I get when I divide negative 27.2 out of y equals negative 27.2 divided by negative 2 times negative 16. 2 times negative 16. 0.85. Look, it's exactly what we thought. 0.85. So this is 0.85. That's correct? Good. So this is 0.85. And how do I figure out what the y is? I just put 0.85 into here and here. You guys tell me what that would be. So y equals negative 16 times 0.85 squared plus 27.2 times 0.85. You guys tell me what that would be. Is that what you guys got as well? 11.56? Yep. That means they jumped, this dolphin jumped approximately 11 and a half feet. That means if you're in the gymnasium, the floor, if that was the surface of the water, would be able to jump over the basketball rim, which is 10 feet, by 1.5 feet, then come back down. That's crazy. That's crazy. You guys want to check it in the calculator? Watch what we can do. Clear this out. I can go to y equals. I can put negative 16x squared plus 27.2x. And if I graph this, my window, how high do you say went up to about 11 and a half? We'll call this 12.
Wow.
12. And I graph that. If I use the max function for this, the x value should be 0.85, and the y value should be 11.56. Let's calculate the max function, which is choice 4. Wait for it. Enter on the left. Enter on the right. Enter one more time. 0.85. 11.56. Perfect. Perfect math, guys. Good job.